Uh, Hi, so today I'll be explaining the Java Spring Boot microservices example. I'll give you the step-by-step guide because so that you can understand how the microservice architecture, the project can be created, API can be created from end to end. Okay, so we are going to use the Spring Boot here. Spring Boot is also increasing because it is a very good framework which can avoid boilerplate code. We have a lot of annotations, so predefined annotations are there, and building API is a very straightforward approach, very easy approach. So that is why I'm going to use this Spring Boot. And you see, when it comes to the microservices development, Spring Boot is always a first choice. Most of the people, they prefer the Spring Boot because it is providing ready-made things and all. Spring Boot, why you can, because Spring Boot is having a lot of features. You have a embedded server is there. You can simply run the application, you can test it. You have a actuators concept to monitor the health and performance of an application. You can also integrate lot of starter dependencies are there. You don't need to include search for each and every dependency for the features, functionalities. Once you include the starter dependency, it will download all the things and it will give you. It will download the respective download. You see, the Spring Boot is a very good example, and as I told you, the features of the Spring Boot, as I told you, actuator, starter dependencies, embedded servers, and we have uh, uh, different endpoint management is also there. You can integrate Swagger also. Okay, there are many features are there. So that is why we are going to use, and also Spring Cloud is also providing a lot of fast options features like Spring Cloud API gateway and cloud config server, Eureka server, discovery, service discovery. So many features are being provided using Spring Cloud along with the Spring Boot. Okay, first thing what you have to do. First thing is you need to create a Maven project. You can see we are going to use a Maven as a build tool. We have a many two build tools. We can also use Ant. Ant is also one build tool. You can also use a Gradle. You can use any other build tool. My build tool is just for compiling the source code into classes and all. And the language is a Java. Packaging is a jar. Why I have mentioned a jar here? You can also mention WAR, Web Archive, Enterprise Archive. But the thing is, it's a simple application, right? It's just a simple application. We are building a jar, and we are using a version 17. Now Java is advancing every day. We have a lot of versions. Latest version is more than 20. You can see more than 21. It reached. You can see a lot of features. Every day they are fixing so many features and releasing a new version for Java. Okay, I require these dependencies for my project. What are different dependencies? Spring Boot dev tools. Why do we need dev tools? Whenever you make any change, okay, you don't need to restart this uh, system. Dev tools helps us to reflect the changes as we made. JPA, Spring Data JPA, Java Persistent API. Okay, you can actually integrate data sources, different data sources. You can also use Hibernate with JPA as underlining implementation, or you can also use JPA for NoSQL databases as well. We are using relational database, which is why I'm using MySQL driver because we are using MySQL. You see, in the note I have mentioned, we have mentioned it. We have used MySQL database in this project. This is one of the project. It was this blog was created by someone in the Greeks for Greeks. I am just explaining. I have not done this, but I am just explaining this. The project done by some other person. I'm just trying to explain how they have done. What the things they used. Just try to understand what they are doing here. First thing is we need to create a database, right? First thing is. We are going to create a employee table having ID, name, email, age. You can see it is simple project. Even the students or any other people can understand. I am not going into the deeper. I'm not going into the deeper design patterns, architecture styles, design, system design. I'm not going into that. I'll explain those things later. I'm interested in explaining the system design features, concepts. I like that because everybody has to understand. Going forward, developing a code is very easy, straightforward. Nowadays, you can see even this with the help of artificial intelligence and source code generators. So many tools are there. They're integrating them into the tools and generating the code within a minutes, right? It's not a big deal now generating the code. The only big deal is to design the system, design the architecture, understand the pain points, understand the cross-cutting scenarios, understand the risk, understand how you can mitigate it, understand the future upgrade status, how scalable is the system. When you are designing a system, it should be scalable, it should be flexible, it should be future proof ready. If you are designing a system with some kind of technology which cannot be upgraded easily tomorrow, then it is a failed design, a failed system. So you should be understand that you should understand, you should take care of that very well, right? That is a very important thing. You see here, we have an employee object. I'm going to have a ID, name, email, and then what they have done, they created a table. They have given a schema named GFG microservices demo. That is the schema name. You see here, select a star from schema dot employee table. Okay, he mentioned the schema dot table name. You're just retrieving the data. Okay, then see the project structure here. He has created a package is configuration controller. Configuration package, he created employee config. In controller employee controller class, this is the controller class. Config class is just having some configuration, setting a configuration details in employee. Entity is a model, we need employee entity. Employee repository, we require a repository in order to integrate a repository. Employee response entity also we created, you see. We need a response entity because once we get the data, we need to map the data to response. The employee service object, okay. Okay, in application.properties file, you see there, what we are doing, we provided a data source URL. Data source spring.data source dot URL equal to jdbc colon mysql colon slash slash localhost 3306 slash, okay, gfg microservices demo. What did we provide here? We just provided the database server. It is running under the port on port 3306. We just pointed that database instance URL, data source URL here, and also database username password. We have to specify it. Okay. So after providing those properties in application.properties file, and where this application.properties file is there, it is created under resources folder. That is not displayed in this picture, but there is a resources folder in a Spring Boot project. You will have this application. You can see here, is there in the image. Okay, it's created here. Under resources folder, we created a static directory, static folder, templates folder, and application properties file. Okay, entity, you can see here, @entity @table name equal to employee. It is very straightforward. We just creating a entity @table name, and all these are column names. Setter, all we have created a setter method and getter method for that entity. You can actually use lambda. Uh, so lambda dependency. You don't need to create all the setters and getters. Using annotation, you can simplify the code. I don't recommend this kind of approach. If you are able to use a lambda um, uh, annotations are there, I think you can use it. Okay, and after that, you can see created a employee repo. Okay, the one thing you have to understand, you need to pass the employee uh, type of object. What is the type of an object? Employee type, right? You need to pass that entity type here, and also id is always integer type. Integer type, anything you can take anything, but I'm passing integer because in our entity we have id. You see, we're generating id, unique id, right? And then you can see for response we are getting id, name, email, and age. And you go there and service, you can see here what we are doing in service. We have to auto wire the employee repo. We need to auto wire model map. Why do I need to use a model map? Because I need to convert the what we are doing. We are doing actually we are using mapper to assign the response to response entity. So that's where we are using it. Okay, it's not a problem. You, actually you don't need a response object also. You can directly get the data in JSON format, render it there. But for standard approach, many people um, use the response entity because sometimes you cannot directly render the object. You may not need all the data rendered by the response. You may just need only few attributes. That time you need a mapper to set the required data. Okay, it avoid ambiguity and confusion, so you need to use that. And employee controller, you see here, you can have the employee controller. You need to auto wire the service and then call the service object here. As you get employee, you are having all these things, right? Okay, you see here. Employee response, employee equal to employee response, get employee ID by ID return response entity dot status, HTTP status dot. Okay. Okay, we created so in the employee config we are creating employee service bean, and a bean should be created, right? When we are going to use that, you can create a bean like this also. There we are creating is a configuration using configuration class. There are many ways you can actually directly use the you create the bean. You can use that. Okay. You see here, okay, we created it. And in PALM file, you see we mentioned all the starter dependencies. Spring Boot starter parent. Okay. And we have a web starter. You see, JPA starter, web starter. We require all this MySQL connector. Okay, DevTools, Spring Boot starter test. We have used all these things. It's simple. We don't need to do much more than that. So once you run the code, once your service is up and running, you can fetch the data simply passing localhost colon 8080 slash employees. You can see here ID, name we are passing AMIA, email, okay, 25. But this is a simple example. I don't see. I want to explain the system more of a architectural design patterns, right? As I told you, now developing a code, whatever the code I have shown here, it can be developed in 2 to 3 minutes or maximum 4 minutes. It won't take much, or 5 minutes. It won't take more than that. It's very simple. You just need to create a entity. I want to tell you one thing. I have developed some code generation automation tool also. What I have done there, you just need to specify the entity attributes that you want to get, and rest of the code, everything will be automatically done by the that auto code generator tool. You can also do that, right? It is not a big deal. Whenever you are going to do some project, you can see it is always the consistent way of creating a project. When you know something should be created in a similar pattern, like it will have a controller, entity, repository, service, and then you will render the data. Why do you need to code all this stuff again and again? You can simply automate the process of generating it, right? There are so many built-in code generator tools. You just have to create an entity, and based on the entity, they will give you complete project structure. It simplifies that. Okay, so don't spend much time on creating a decoration. Don't spend much time on decoration part. Rather, you can spend on a logic part, because that is the important thing. The rest of the project common, because it is a very common code, consistent way of creating a project. When you see something is auto routine task, you don't need to do that again and again for every time. You have to automate that is the main thing, in the software industry. When you are doing a things routine things every day, it gets bored you, right? It's really boring stuff for you. You take banking industry, they always do the stuff routine way. It's a boring job, right? In banking industry, customer visit the bank, and they open the banking application. They will, what they will do, they will perform the core banking operation using applications, softwares, whatever we developed. So it is a routine thing. In software industry, the primary goal of a software developer is to avoid the routine stuff, routine task. Okay, they have to create a automated stuff. They have to automate the things that can run on their own, right? You don't need to do that. That is the main primary goal. You have to generalize the things, you have to automate the things, you have to simplify the human effort, you have to reduce the time consuming stuff. So that is, don't waste time on building the common structure. Try to create some automation tools. Okay, now I want to explain, Spring Boot features. I will explain. You see here. Somebody see. We will go this flag. Know about Java, Spring Boot, microservices architecture. You see, nowadays developers ecosystem by JetBrains. You see, 67% people are using Spring Boot, right? That is the significance of the Spring Boot. What are the Spring Boot microservices? Why 67% people they are adopting the microservices? Why? Because you see, it is providing a ecosystem, and it is avoiding lot of boilerplate code, right? And microservices are nothing but, we are actually building services as per the domain driven model. For each domain, for each functionality, we will create a separate atomic self-contained services, and they'll act as microservices. And as I already told you, so many features are there with embedded servers, automation, auto configuration, production ready features. Spring Boot framework actually is simplifying entire development process. You can see here Spring Boot, a pool of Spring Boot framework benefits. The main thing is the speed of development. You can develop a project in faster way. Scalability, you can actually scale the services, independent services, microservices, right? Let's say for example you have 10 microservices. Whenever demand is on one particular one service, you don't need to scale all the services. You can only scale that particular service. It's a dynamic nature, you can see. Flexibility is there. Rapid development, right? uh, Modularity, lightweight services, right? They are not heavyweight services. You can develop API with lightweight features. You just need to specify the entity, and the rest of the things, that will be converted into endpoint. So that can be used as API. We can also use that API in other services also. We can call that. And also cloud native services. You can also containerize the services and deploy them in a cloud cluster also if you want. So many benefits are there. You can see quick start, extensive ecosystem with the Spring Boot, ease of inter-service communication. We can actually establish synchronous and asynchronous communication. You can choose the options like REST, gRPC, messaging queues, depending on your requirement. Hmm. So you see, in Java we have a multi-threading support. What this guy is telling you, how Java helps in microservices development. He's telling Java is widely used programming language known for its security and platform independence. It's a mature ecosystem. Extensive library support make it an excellent choice for developing microservices, where the Spring Boot framework of Java strengthens this architecture even further, adapting scalability, maintenance to its shelf, right? Feature shelf. Some of the Java's key advantage in the context of microservices are it's a multi-threading support. In this, you can run multiple processes concurrently, right? This comes in handy, especially when your goal is to build responsive, scalable apps. Multi-threading support is there. Okay, Java concurrency. It also makes it perfect handling for multiple microservices that need to operate in tandem without slowing down the entire system. You can understand concurrency is running multiple services parallelly for performing an option. Multi-threading in a single process, multiple processes does the work, simplifies it. Okay, now I want to explain advantages of Spring Boot microservices. You see, ease of use, security feature, flexibility is the main thing. Enhanced communication, improved performance. Okay, all these are okay. Why businesses can benefit from Spring Boot microservice? See, use of Spring Boot microservices. What are the domains they are using? Lot of e-commerce platform they use the Spring Boot microservice. I want to explain this concept here. Why? You see, e-commerce platforms are they will generate lot of thousands of applications, right? Thousands of applications. So e-commerce platform is a very biggest market in the world. E-commerce applications, right? You see Amazon, Flipkart, eBay, so many e-commerce platforms are there. Many businesses they are running their businesses online through e-commerce platform, right? So they need a platform application. They need their website to be ready, which would be flexible. If they are running a crores of I mean, the business is generating crores of revenue. The capital is also very huge. The revenue, they are getting revenue, huge revenue benefits every year. If they are getting it, their underlying infrastructure should be standard and secure. If something is going to break, then it will result a lot of currency, right? A lot of dollars. They'll get the lot of dollars in loss. That is why time is very valuable for them. Whenever the business became bigger in online, right? uh, as a e-commerce application. If so many customers are using it for 1 day or 2 days, if server is down, imagine how much loss the company will face. So e-commerce application should always be up and running. Once they have infrastructure, they should be proper, they should be properly secured. Okay, they should be properly maintained, otherwise it will result lot of loss in their business. So that is why e-commerce platforms um, is a very biggest platform in it, even nowadays in our digital India, right? So many startups are coming for solving so many issues in so many business, different niche they are selecting, and they are actually starting the startups in digital era, right? We are moving towards the digital era. So one of the mm, best thing that India is doing, they are trying to digitize some businesses, and they are bringing a lot of digital revolution here. So e-commerce platforms and e-commerce applications are very important. For developing them, we are using a Spring Boot microservice. They need to develop in a faster way. Speed is very important, and the flexibility should be there. Future ready, future upgradable. When we take all these things into consideration, Spring Boot microservices is a very good choice. That is why most of the people are preferring these frameworks to build an application systems. And next thing is financial services. What is this financial services? Banking applications, financial institutes, okay, which deal with the money. They always deal with the money, transactions, currency. For that, they need to secure the data. They need to secure applications. They need to secure applications, and they also need transaction supporting applications, right? So that is why they need a Spring Boot microservices framework also for developing it, because the ecosystem is extensively providing a security features. You can also integrate third-party security frameworks as well for banking and financial systems, because security is a primary concern when, for banking applications, right? They always deal with the money. If there is a breach in security, they will lose a lot of money for banking industry, financial institutes, stock exchanges, stock markets, or any investment related financial institutes. They always deal with the money, right? You need to secure the applications, otherwise it will bring lot of loss for you. At the same time, the development and maintenance is also very important for banking application. Every day they may require lot of changes, enhancements. So that is why they'll follow the agile development approach. Okay, in software development life cycle, they prefer the agile sprint. They'll follow the sprint process. We'll have a lot of sprints in agile development process, right? For every sprint, they'll push certain changes. They'll make changes and they'll push the changes to the production. That way, the new changes will come into the online. And also, I worked, one of the banking projects like personalization, where we will show the advertisements for logged in customer. Okay, we actually uh, process some rules, and we will look at the customer interest, customer likelihoods, and also we'll see the click stream counts. Based on this data, we will actually personalize the offers and what kind of advertisements the customer can like them. So if they can click that advertisement, so we will provide some benefit, related benefits in banking sector. For example, you take for American Express, customer using American Express card. So he might have used that card for shopping books, or he might have used that card for restaurant most of the time. For his, then we will understand. Okay, this guy is a foodie. Since that guy used a American Express card for eating a food in many restaurants, then we will understand, okay, this guy is a foodie, he likes the food. Then which is why we will personalize food related offers. We will create a banners related to food related offers, and we will showcase that banners there. For example, if you use this advanced card, it will give you concession in the restaurants. That banner will show like that. You got it right? So that way that person may upgrade his card to food related card. So it is called a personalization. People may have different interests and different habits. Some people like restaurants, food. Some people relate like the entertainment. Some people like the uh, shopping. Okay, their interest, their habits, their depending on their interest and likelihood, we call it as a likelihood in business term. Depending on that likelihood, we will personalize the offers, right? We I worked on one of that project also, and I also worked on payment gateway project. So one of the example I'm telling there also we used um, that is also another example, but listen, this is one of them. I also worked in JP Morgan there. I worked, we actually, there is a legacy system, banking application. It was developed using a COBOL or mainframe. And what we have done, we actually migrated that project into Spring Boot microservices. Also worked there. So you see, banking and financial services system, they always use Spring Boot. They are still using it, Spring Boot microservices. So it is also a very important framework for that financial services. Healthcare systems, healthcare system. Okay, I never worked on healthcare systems, but healthcare systems also require a very good framework like Spring Boot microservices. Patient management, appointment scheduling, billing, medical records, separate services. They need a separate service. It is a big domain, right? It is a healthcare domain is a very big domain. So when you actually segregate different functionalities, we can actually create a lot of APIs, many APIs, right? Independent APIs, and also secure data integrity. Performance is also there. Basically, that healthcare also require the Spring Boot. Media and entertainment company. Okay, you see the media nowadays. They are using this framework also involve basically streaming content, content distribution, digital media. Okay, for that also we can actually build these services. So all I want to tell you is here, the Spring Boot is Spring Boot microservices. This framework is being used by different business domains. Okay, they are using in e-commerce platform. They are using in financial services, banking services. They are using healthcare systems. They are using in media entertainment domain. You see, so many business models are there, right? There are so many businesses, they are using it. Okay. And the technological advancements and features. Recent latest features, Spring Boot 3.2 supports Java 21 virtual threads also. So late recent feature Java 21. Okay. Okay, Graal VM for building native images. They also help. I'm not sure of this concept. I'll explain you later on this. Okay. You see, latest releases also include Spring Boot support for Java 21, Spring Framework 6.1.3, Spring Data JPA 3.1.3. You see, all these things are there. Integration and ecosystem. Spring Boot integration with popular libraries. And it is very easy, like tools such as embedded Tomcat, GT, Undertow servers enhance its utility. Framework also support extensive tools like seamless integration with messaging systems like JMS, ActiveMQ, AMQP, RabbitMQ, Kafka, Pulsar, Simplify. So many messaging systems we can integrate it. Very good option is a Kafka if you want. build a streaming application, asynchronous system. So using a Kafka, you can actually transfer lots of data, in less time. It is a very good framework. Future trends and predictions. Some of the emerging trends in microservices: adoption of CNS standards, new app layer protocol replacing HTTP REST, rise of polyglot framework. So many. And additionally, cloud engineering using DevSecOps, API-driven infrastructure is also becoming quite prevalent in handling multiple cloud platforms. So, so many use cases are there. The conclusion is the Spring Boot microservices with Java offers a flexible, efficient, scalable solution for building modern applications. Always remember that. With the use of manageable services, business can reduce the complexity. It will improve the performance. It can adapt to changing needs and more easily, right? You can actually deploy the services in any platform. You can deploy it in on premises, you can deploy it in cloud, you can deploy in cluster, you can deploy in any server, right? It doesn't matter whether you are running a startup or managing a large enterprise. Adapting a Spring Boot microservices can provide some promising benefits that have been discussed above. With its strong integration with the Java, widely variety of tools, a vibrant community, a Spring Boot is an excellent choice for microservices architecture. You can hire a dedicated Java developers to harness the power of your microservice. Okay, you can create applications that are not only efficient but also responsive to the needs of your users. However, not everything has to be done alone. You can take charge in competitive era with the help of reliable offshore developers and check how businesses are perfect with just a small and simple shift in your framework, right? So the thing is, overall, Spring Boot microservice is very good choice if you want to use it. You can create a API very easily. Uh, the ease of development, the faster development speed. Speed is the factor. How fast you can develop it, you can develop it very fast. You can simplify how you can actually it avoids the complexity. Even you can develop a complex system because it is a microservice based architecture. Right? You can develop a complex system with this Spring Boot microservices. And ease of maintenance, development, deployment, agility is there. For every sprint, you can develop a couple of services. You can upgrade, give the patches. You can deploy them wherever, whenever you want. You can actually, it is a very flexible framework. As I told you, you can either deploy the applications either on premises or your own server, cloud servers, or cluster, whatever it is. It is going to make a complex system in a simple way, as simple as the, application, because you can actually customer developer will have a control over the complexity of the application if you go for a Spring Boot microservice. I hope this would help you, and thank you for listening. Thank you.